Good morning, ladies and gentlemen. Welcome to the second day of Concawe's 14th Symposium. I'm delighted to welcome you here for our third and fourth session that will be taking place today. My name is Alain Mathurin, Communication Director for the Association, and I will have the pleasure to moderate the two upcoming sessions. Yesterday we had two sessions, one on the technologies, another one on carbon, CCU, and circularity. We've been looking how those technologies could be integrated in our refineries. We've been discussing new value chain, decentralization versus centralization in the refineries. We've been talking about what kind of carbon could be used. We've also been looking about circularity as a new model for developing all those fuels. Today we'll be looking into two specific sessions. One will be focusing on aviation and maritime, two hard-to-abate sectors. And the second session this afternoon will be looking into the alternative fuels towards 2050. We'll again be lucky to have distinguished speakers with us in both sessions. And let's start with the first one. Before that, I would like to just give you two little numbers because we're very proud and very happy about that. We had about 500 people that connected yesterday, individual logins. That's really great. And practically, you can of course interact with our speakers. You have on the right side of your screen the chat box. Just type in your question. You define whether you want it to be on your name or anonymous. And this will come on my laptop and I'll be able to put these in the panel. There will be two opportunities, one after each individual presentation and one during the panel. Finally, remember our LinkedIn account. There will be news posted there regularly, so don't hesitate to follow us on LinkedIn. It's the Concawe page. With this, let's start with the first session, and I'm delighted to introduce our speakers. So, aviation and maritime, two hard-to-abate sectors. We have, to discuss this, Luca Bertuccioli from E4Tech. Good morning, Luca. I have with me here in Brussels in our studio, Dr. Stephen Dooley from Trinity College in Dublin. Good morning, Stephen. We have from the UK, Tim Scarbrough from Ricardo. Good morning, Tim. And finally, calling from the Netherlands, we have Jurrit Bergsma from TNO. Good morning, Jurrit. So, we'll start. The first presentation will be with Luca Bertuccioli, if you allow me to introduce you very briefly. You have over 20 years of professional experience in the energy and aerospace sectors. At E4Tech, you have the oversight for complex modeling and novel technology, and work on hydrogen and fuel cells, sustainable fuels for aviation and road transport, system-level topics, low-carbon energy technologies. Before joining E4Tech, you worked at United Technologies Corporate Research Center. Luca, the floor is yours.
Thank you. Thank you for the introduction. Okay, just waiting for the slides to come up. So yes, I'll be giving you an overview of the project that we're calling the Aviation Deep Dive, and also some preliminary results, because the project is still ongoing. So in terms of my outline, I'll just introduce you to the consortium team, the objectives of the project, the methodology, and then there's quite a lot of ground to cover here. So I'm really just kind of giving you an overview of some of these topics of how technology gets into new aircraft families, what the rollout of these aircraft might look to 2050, just a snapshot of what some of the technologies might be in these new generations of aircraft, and then looking, when we pull that together in terms of looking at the aviation system and this sustainable aviation fuel, what does that mean? What might that mean in terms of aviation emissions? And in order to make that a reality, what would you need to do to ramp up the sustainable aviation fuel production? And then just finish on the next steps of the project because it's still ongoing. So I'm just the mouthpiece. Obviously, the work is being done by a team of people. There are three companies in the consortium. So E4Tech are the project manager, and we're responsible for the work on alternative fuel characteristics, as well as the ramp up of production of those fuels. Aviation Air Transport Analytics are doing the technology and aircraft performance assessments, as well as the integrated aviation system modeling. And Frontier Economics provided some review of policy projections, roadmaps, and some of the historical evolution of the sector. And then, of course, we've been very closely working very closely together with the Concawe members and the program office. And in particular, the steering group of Concawe members have been, very, very fruitful collaboration, sometimes asking very tough questions, which are very welcome. So, apologies. So in terms of the objectives, what we're trying to do is join up the analysis of the aircraft technology rollout, the dynamics and economics of the aviation system as a whole, and as well as the production ramp up of low carbon aviation fuels. And in some sense, our guiding question is really what might the future aviation system look like, but taking into consideration the realities of rolling out new technology into the aircraft fleets, the dynamics and economics of the aviation system, and then also just taking a look at what current and possible policy signals might be that could drive that change. And if you want that reality to happen, what would you need to do on the low carbon aviation fuel side to make that future realizable? So the methodology, at the heart of the analysis, and I apologize, this is because of the way it's being displayed, but there is a graph here with lots of results, but I will show you some of the sample results afterwards that you'll actually be able to see. But at the heart of the analysis is this aircraft integrated model that Air Transport Analytics run. And that models the dynamics of dynamics and economics of the aviation system, as I mentioned. And upstream of that, we're doing a technology assessment and basically using that to put together some technology packages. So that's an input into a model. And then also we are providing sort of characteristics on the sustainable aviation fuel, both in terms of their thermophysical characteristics and emissions factors, and then also the production ramp up. Now, the thing to understand about the A model is it's really very detailed. It basically takes external inputs such as demographics and macroeconomic inputs such as population growth, GDP per capita, oil prices, policies, technologies, etc. And then it models the flights between almost 1,200 airports in almost 900 cities, also accounting for things like modal competition between city pairs where that is relevant. And one of the key things here is that the demand for aviation for flights actually is an output of the model for each of the scenarios that it considers. So it is taking these external drivers and the historical dynamics of the aviation system, and then using those to determine what the demand is, accounting for the fact that maybe with different policy signals, prices might go up, or if you have more technology rollout, prices might go up. So the demand is not imposed externally, it is actually an output of the model. And that's important because it sort of changes the perspective of what the results might mean. So stepping back, apologies, these are a little bit hard to read, but how does new technology get into operation in aircraft? So one thing you have to understand there is there's two sides to this. One is airlines have to decide to buy new aircraft, and then the airframers also need to develop those new aircraft. The typical economic life of an aircraft is 20 to 35 years, which means that the fleet turns over relatively slowly. And when airlines are considering buying new aircraft, they balance what the revenue generation potential is, and that means how many people can it carry, how far, how fast, and they have to balance that against the cost of acquisition and the operating cost. And the key piece of the operating cost is obviously fuel. What the airlines would generally like is ideally the acquisition cost is no more expensive than the previous generation of aircraft. And they usually aspire to have at least a 10% reduction in operating costs relative to previous generations. And that is to justify the very large investment in this aircraft, in these new aircraft, that they are going to be operating for 15, 20 plus years. On the airframer side, they need to meet these sort of fairly high targets of the airlines. And it takes about 5 to 15 years of basic research to get a technology to a point where it's mature enough that an airframer might consider putting it into an aircraft. But then you can't just take an individual piece of technology and bolt it onto an existing aircraft. They actually need to basically come up with a whole aircraft concept with a bundle of technologies that meets these performance improvement objectives. And once they have this bundle of technologies that they think is a concept that they can do, it's 5+ years to actually turn that into an aircraft and launch it into service. And then obviously at that point it starts to make its way into the fleet, but obviously you're only replacing older aircraft as they're retired. Now, the other piece of this is that individual airframers only have the capacity to run more or less one aircraft development program at a time, both in terms of capital, but also in terms of engineering resources. And so typically there's about 15 years between cycles of aircraft generations, obviously impacted by external macroeconomic events like the recent years where there have been big disruptions. But what this means is actually that you can't basically integrate, you can't launch new aircraft all at the same time. The different models come out sort of in a staggered fashion. So what might this look like? So we actually did all of the analysis, and we've basically aggregated all of the fleet into 4 families that cover about 95% of the flights and fuel burn. So these are, the green is regional, light blue is short haul, purple is medium haul, and yellow is long haul. Those are sort of the 4 families that we've covered. And we've done 2 technology scenarios. One where it's relying on the use of essentially drop-in SAF, so kerosene-like fuels. And then there's also one where we're including the use of hydrogen. In the SAF scenario, new generations of aircraft launched in the 2030s, 2035 timeframe, and the second iteration comes out in 2045, 2050. With the introduction of hydrogen, we've anticipated that the entry into service would be delayed by about 5 years because it's a bit more disruptive what that means in terms of the change of technology. But what this really effectively means, if we're looking at this window to 2050, is essentially there's only one window for a new aircraft generation to be launched, and that's in this 2030 to 2040 timeframe, depending on whether you're looking at with the inclusion of hydrogen or not. So just a really quick snapshot to show that the technology bundles that we put together do actually meet the objectives that we sort of laid out. So on the right, there's a graph which shows fuel burn change with versus entry into service. And the current aircraft are here in the red dots, and the successive generations, you can see it's going down by about 10% per generation, except for this last one at the end. And actually, what we've done here in the 2050 timeframe for the long haul and medium haul is we've actually introduced more disruptive concepts. In this case, these are flying wing aircraft, which is why it's sort of deviating from sort of the historical trend, because it's a much more disruptive technology change. But there's a whole suite of technologies that are included here, both in terms of aircraft technologies, but also operational air traffic management options, as well as ground operation options that have been included. And all of that is factored in to give these sort of typical performances. So very, very preliminary results here. I'm looking at just one scenario. And this is a scenario where we have, which we call global carbon price. And it assumes that there is the $150 per ton of CO2 carbon price from 2025. On the left is a graph of air travel demand, and the different colors are the range of external scenario, demographic and macroeconomic inputs that the AIM model runs. So running from red high to this sort of greeny blue color, which is decoupled, which essentially says that demand for aviation deviates from the historical trend and does not grow with GDP per capita in quite the same way as previously. But what we see here is that demand for air travel increases across all scenarios. In the middle graph here, we have the fuel demand. This is fossil kerosene, the lines at the top. And at the bottom, we have SAF coming in. So SAF does come in, but it only comes in scenarios where oil prices are high, and significantly, the only scenario that starts to approach carbon neutral growth by 2030 to 2050 is the one with the lowest overall growth for the aviation system as a whole. So this is quite far from the aspirations of the sector in terms of what the targets are of meeting emissions reductions. So what does this look like on the production side? Well, we built a preliminary sort of SAF production ramp up, and each of these wedges in the curve is a different route, which I'm not going into the details right now. But this ramp up that we have put together here is essentially enough SAF by 2050 to meet the equivalent of the Refuel EU target, but globally, not just in the EU. But what this gives us is by 2050, we end up with about 7 exajoules per year of fuel. But this is the piece that I think is particularly relevant, perhaps for the Concawe audience, is this means building about 1,500 plants by 2050. And by the end of that period, the construction rate is about 200 plants per year to get to these kinds of volumes. Now, this 7 exajoules is only about a third of the overall fuel demand in 2050. So it's still a long way to go. So in terms of next steps, what we are working on is to refine the analysis. We have to be somewhat careful here because our models are slightly uncoupled in terms of the supply of fuel and the demand from the aviation system. So we have to make sure that is taken care of. And we're developing additional, more ambitious scenarios that start to look more like the aspirational targets. So one would be to achieve carbon neutral growth by 2050, but not with the weakest growth scenario, but with something that is more like a central demand scenario. And then we also want to put together a scenario where we end up with 100% SAF or 100% SAF or SAF and hydrogen meeting 100% of the fuel demand by 2050. And obviously, when we have those, we now have to understand what the implications of the required plant rollout would be for those new alternative fuels. So that's where we're at with this project. We're still plowing ahead, and I would be very happy to take your questions. Thank you. Thanks for your attention.
Thank you very much, Luca. Thank you for this presentation, and thank you also for the time management. It's really great. I'm just quickly looking at our question feed, so I'll invite people not to forget. Just go ahead, put your questions on the right side of your screen. You have this box, just use it. In the meantime, I have a first question for you, Luca. In regards, you've given this quite interesting information about the window of opportunity for technology shift, and basically there is one, and we are around 2030, 2035, if I look at it from the graph you shared. There is a lot of discussion about hydrogen. Today, how realistic is it to imagine that hydrogen could be part of that window of 2035, because I think it's slightly delayed. There have been some announcements from some big aircraft builders that 2035 would see the start of that. Is this really realistic, given the challenge of that fuel or that energy source?
Right. It depends what question you're asking. So certainly from a technical point of view, is it possible to launch a hydrogen-fueled aircraft by 2035? I'd say the answer is yes. Can you put the whole system together? Also, yes. You just have to have the ambition to do it. And the boundary conditions aren't quite there yet, right? Because there is no signal to say we really need to make this shift in technology. But it is definitely feasible from a technical point of view. It's also feasible to build green hydrogen production capacity in that time frame. But the challenges are not small, right? Because it's a whole chain. It's not just putting one aircraft into service or providing hydrogen to 1 or 2 airports. You obviously need to scale it up from there.
As a follow-up question, could that be something that could start only for the EU, for instance, given the stronger policy drivers?
It could, but the policy drivers would need to be substantially bolder than even what we have there. So in the analysis that we've done on the hydrogen, hold on to your socks. We had to put carbon prices at $400 per ton to get hydrogen into the mix. And so it just not to fixate on the $400 per ton, because it's not an exact number, but it just gives you an indication of how much bolder the signals would need to be to absorb that technology transition, because it is an investment in a lot of new technology, that the fuel is more expensive, and also the aircraft use more energy on a per kilometer basis than the equivalent kerosene aircraft would. So a not insignificant challenge.
We'll probably come back to this price when we have the panel discussion. We'll be engaging with the other speakers, looking into the business model of the aviation sector at that moment. Another question which comes to me is about, you mentioned one number, 1,500 SAF plants to be built, but only able to supply 1/3 of total demand.
Right.
When you mean SAF, you mean non-hydrogen fuels?
Those are kerosene. Yeah, that's right.
In time, bridge the gap by becoming that key energy source that could supply what's missing, or will we have to go beyond 2050 before we can get to a 100% decarbonized sector?
So if you posit that the first time hydrogen aircraft could enter into service would be 2035, it's pretty clear that you would not be out of kerosene aircraft for quite a while beyond that. At least another 20 or 30 years before the economic life of those aircraft will be done. So kerosene type fuels are not going away in the near term, but they hopefully could be lower carbon versions of those fuels. So if hydrogen is part of the solution, it will be alongside kerosene, certainly for the next 30, 40 years. But it can help bridge that gap. And also, obviously, you can do more on the SAF side. The point of the 1,500 plants is to just underline just how ambitious something that is actually quite modest compared to the sectoral aspirations is. And those plants, that by their nature, these biofuel plants often are smaller than conventional fossil refineries. And so this isn't 1,500 refineries as we understand them now, but it is still 1,500 plants, which is obviously a very ambitious rollout plan and engineering effort, right, to actually make that happen. And if we try and get to a scenario which we haven't looked at yet, but where SAF and hydrogen are meeting all of the demand, obviously that number is going to be much larger.
Let's keep that for the panel discussion later. Thank you very much, Luca, for these first questions and answers. I'll now turn to our next speaker, sitting next to me here in Brussels. Stephen, welcome again. And maybe a brief introduction before I hand you over the floor. This is also good to have. So, Dr. Stephen Dooley is Associate Professor at Energy Science in the School of Physics, Trinity College Dublin, and an interdisciplinary engineering scientist of a chemical bias dedicated to fundamental research in clean energy technologies. You're the author of 51 peer-reviewed research papers, accruing 2,958 citations and an H-index of 31. You also worked as an expert on fuels for the European Commission Transport and Energy Work Programs on biofuels for the International Energy Agency, and you've been recently named an elite expert by Presence Consulting for your work with industry on engine-fuel interaction. Tell us more about that.
Yeah, I can't believe you read all that out. Thank you, Alain, for the introduction, and indeed to Concawe for the invitation to come and speak today. So I've been asked to give what's really a perspective in identifying key R&D areas towards sustainable aviation as a sector. So it's a complicated situation. So I thought I would start just by explaining the importance of aviation to Ireland. So Ireland is a small country, and what you may not be aware is that as an island, it actually commands 60% of the global aviation leasing market. So there's 50 aircraft leasers operating in Ireland, and that includes 14 of the world's top 15. So it's very important for us because it supports a lot of jobs, And a lot of the leasing community then are concerned about the sustainability of their business models in light of the climate situation and the advent of sustainable aviation fuels and the likely cost penalties that that's going to have. So secondly, there's a major airline based out of Ireland, which is Ryanair. You'll all be familiar with that. They're one of the major airlines in Europe. They're also, because of that, a major polluter, and they're aware of this. They're very concerned about it, and they need to take some action on this. They realize this. And so recently they have given us essentially at Trinity College what is for us a large gift of €1.5 million to conduct research in this area that can lead to some innovations that can make aviation more sustainable. So this is what we're doing. Okay, so a couple of fundamentals before I get in to what I see as being the R&D challenges. And the first one is this word sustainability. In the context of aviation, what does it mean? So we have to think about what sustainability really is. So the definition is what's on the slide there. It's the quality of being able to continue over a long period of time. So some activity over a long period of time. So the way that we look at this, there's actually probably three types of sustainability, at least three. So the first is the one we all typically recognize, which is sustainability of environment. So can we continue our way of life in an environmentally benign way? So for aviation, the work that we're doing with and for Ryanair is about reducing aviation noise. And then the major aspects are about reducing the CO2 footprint, and that involves different deployments of sustainable aviation fuel. So not only CO2 footprint, but we shouldn't forget, as one of the speakers mentioned yesterday, other pollutants, so smoke and NOx also. So environmental sustainability is key. Talk to people who actually run airlines and run aircraft, either by leasing or making and selling these things, and what they really worry about is the sustainability of their profits and investments. So if the fuel costs are going to rise because the technical quality of sustainable aviation fuel is higher than conventional, then all of this comes into question, and so they're quite concerned about this. Airlines will be a little bit cautious about giving you precise numbers, but what you can take it is that fuel costs are about the biggest cost with labor costs in the operational cost in running an aviation activity. So the IATA puts that number in 2018 at about 20% of operational costs. And then you could imagine that a low-cost airline flying short haul, that proportion may be quite a bit higher than that. So we have the sustainability of the environment juxtaposed with sustainability of profits and investment. So as one of those rises, what does that mean now for the sustainability? A third type of passenger demand. So how secure really is the consumer demand in actually supporting with their money, with their earnings and their choices, their use of their time, supporting the true cost of sustainable aviation. So the first and second types of sustainability there are probably more easy to conceive, but the third will be a result of the interaction of those two things. So this is the three elements of sustainability that we somehow have to bring into harmony. So we see what's on the slide there as the seventh Sustainable Development Goal, clean and affordable energy. In the context of aviation, in the near term, that certainly means synthetic aviation fuels, what used to be called synthetic aviation fuels, now called sustainable aviation fuels. Okay, so a piece of fundamentals, and a thing that I try when I speak to get everybody to appreciate, is about liquid transportation fuels and what they are. So what we're really talking about here when we talk about sustainable aviation fuel, it's a piece of the pie that is of overall liquid transportation fuels. So the concept that aviation fuel is connected to maritime fuel, is connected to ground transportation fuel, and these form what I call a continuum of transportation fuels. So it means if we affect the supply of one of those sectors with some particular feedstock, moving into the 2030 to 2050 time frame, we know that we will be using more electricity. We know that we'll be using more biologically derived carbon and hydrogen, which is fundamentally what a fuel is. And we have some pretty good information about how those new energy sources will penetrate the different sectors. And the message is that Aviation is going to be the more difficult one to decarbonize, and that's because of the technical quality of the fuel. So ground transportation, maritime transportation perhaps are a little bit easier to decarbonize than our aviation transportation. And so the concept here, the second key concept, is that the fuel quality, we should start to think of the fuel quality as being matched not just to the performance requirements of the application, but also the nascent quality of the feedstocks or the renewable energy sources that we will use to displace conventional energy sources, which in transportation context is crude oil. And then the third point down there as a concept is that for all of this to be affordable, and the previous speaker showed some evidence of this, we need to use as much of the existing infrastructure as is possible. And for sustainable aviation and SAF, this is really a key requirement in that the fuels must be drop-in. So it means that we have to essentially produce something that looks very similar to fossil kerosene. Okay, so now some key R&D areas. So I have 5 suggestions. Some of this is happening. Some of this needs to happen a little bit quicker, I think, if we're going to realize things by 2030, 2050. So the first is about the techno-economic gap to fossil Jet A. So we need to work quite a bit harder, in my opinion, to know and reduce this techno-economic gap. So there's some very nice work presented by Alba here yesterday on the techno-economics of e-fuels. So that would be, a very perfect example, and I really look forward to reading that report. But the concept is that we know that conventional fuels will be at a lower price than whatever combination of renewable, sustainable fuels, whatever you want to call them. And we need to get information on what that price gap is very early in the R&D cycle, probably earlier than we're having it now. And this actually, then when I try to implement this in my own work, I realize that it's actually a skills and training deficit. We're probably not training university graduates, PhD researchers with a sufficient knowledge of techno-economics, not just techno-economics, but also life cycle analysis. And what we need to build are these skills as sort of lenses by which to view all of our research and development through. Because if we can do that, then the reality of deploying that becomes a bit more serious for us at early stage. So this is number 1. Number 2, regarding policy, so research and development policy. Right now, we're probably viewing the different types of fuels and their applications as distinct things. So a set of policy and R&D measures for maritime, and another set of policy and R&D measures for aviation. And these are actually connected, all right? So we have to derive biological carbon and hydrogen or electricity to contribute to these sectors, and those derivations, the sources of those things are going to be the same. So we need to make sure that we don't create a conflict between the different sectors, and if we can, if possible, can we prioritize the high-grade feedstocks, such as oils or waste lipids, for the high-grade applications. So the requirements on SAF, the technical requirements for performance, are much higher than the technical requirements for ground transportation or maritime transportation. So perhaps we can start to think of a set of measures that will allow lower grade feedstocks to be used for these lower grade, but still highly challenging applications. So what I've called this is a fuels continuum holistic approach. Okay, number 3 are some measures to increase the SAF supply and the market competitiveness. So right now, if we just make a simple statement, it's probably true that SAF is technically feasible. We can make it, we can deploy it and get it working in an aircraft and in the aviation infrastructure, but we can't make a profit selling it. So it's technically feasible, but not market feasible. So we need a whole range of measures to do this. The new European directive ought to help a lot with that, but the scale of the argument is so vast, we need a lot more measures. And again, the previous speaker gave some nice information about that. So a particular R&D challenge for us is that currently SAF is certified to 50% usage maximum with fossil jet. Now obviously, that'll give us about a 50% decarbonization at best. So we need to start to move the dial up toward 100% SAF utilization by certification. So a key challenge for us there, and we'll do some of this work as part of the Ryanair interaction, but our more efficient and more science-orientated methods to escalate the screening process and the evaluation process toward using very small quantities of fuel and away from using the hundreds of thousands of liters that are needed for a full approval as the technology exists at the moment. So this is all about really deriving a greater expertise in our science of SAF and start to study this as an actual topic. So this is number 4, to elevate the EU competence and knowledge brokering ability on the topic of SAF. So a couple of examples there. When we talk to the leasing community and the airlines, these are the people whose businesses are at risk by an increased operational cost, which they can make a business case to absorb. But what they really, when we speak to them, what they really say to us is, we can pay for this stuff. We might be happy to pay for it. It's going to be a higher price, but we really need to know that we're getting the greenhouse gas saving that's being said that's available. So improved rigor, so more detail, more analysis, and definitely specificity on the specific greenhouse gas savings of specific SAFs. So that's coming from specific regions, using specific feedstocks and specific processes, and really to start to know this at the process and indeed the systems level to a very high confidence interval. The second is the concept for the EU of what's labeled here as an EU SAF clearinghouse. But really this is part of a knowledge house that can focus EU efforts on deploying sustainable aviation fuel. So that could be a distributed center of a lot of people studying what sustainable aviation fuel is, how we can get our hands on it, and how we can push it through the certification protocols in a much more investment efficient way. And in this way, start to catalyze a very competitive market with the expectation of driving down the cost. And then another point which comes up when we do our engagement with fuel producers and researchers is that we can use biomass to make a lot of fuels. And again, the point was made yesterday that simpler fuels are much more affordable to make than complex fuels that look just like fossil. And this is definitely true. We see it all the time in our research that we can make a burnable fuel that would be compatible with an engine, at least in terms of testing. But the barrier comes whenever we compare it to existing legal standards, and the oxygenated fuels that typically result from biomass usually fall down on some of the cold flow properties in comparison to conventional fuels. So a re-inspection and maybe a discussion. I know that fuel standards are very important and they're there for very good reasons, but some re-evaluation or means to re-evaluate those versus what we can produce easily and affordable from renewable feedstocks would be very helpful. And so then the big thing, and my last point, about bringing all of these sustainabilities in harness is really about getting the public involved in this discussion and bringing them with us. So what I've labeled here is social sciences and education, so persuasion activities of the public, and this really involves informing them. So the example of this is right now, if you look at the facts or the stats from reputable agencies, we use really minuscule quantities of sustainable aviation fuel in the energy system. You may not get this impression when you're walking through airports. At least my impression when I walk through an airport is a lot of people are given the impression that we're already doing this, when the reality is that we're not. So we probably need to tell the public more exactly where we are on this topic and exactly how technically challenging it may be, so that we can ask them to modulate their choices a little bit and also hopefully bear the price in the end. The consumer is going to pay for this in one way or another. So I think it's very important that we start to inform them. Okay, so thank you for your attention, and we'll look forward to some questions, I hope.
Thank you very much, Stephen. Yes, indeed, there will be questions, and I have seen quite some questions coming in on the feed from the chat box. You've just referred to better informing and educating the public, and you also mentioned the acceptance of probably higher prices to travel. One of the companies you mentioned is in the low cost aviation I'd say, dimension. How much do you see a risk to see the end of those kind of flights and moving from low to medium or regular prices?
Yeah, I mean, so it's, the honest answer, and we should be prepared to say this now and then, is that I don't know. That's about the future. There is a risk, and I think from the information that's available there now and from thinking about it, different for long haul than for short haul. But obviously, if the cost of the energy source, which is 20%, let's say, of the operational cost rises, then there's going to be a higher price placed on the consumer. And then the question that results is, does the consumer want to do that anymore? So it stands to reason that there is a risk. How real is it? It's going to be changed, but we need research and development to start to answer this.
Yes, because in fact, low cost has triggered a new way to travel, short trips, shorter distances, quick jumps from one place to the other. This could put at risk a model in tourism and the way of traveling.
Yeah, so I mean, the importance of this, for the European Union in particular, with tourism, is it's not to be understated. Regional airports have resulted, whole tourist regions have resulted from the availability of low-cost travel, so it's an extremely important topic. And what we would see is that really measures to drive down the price of SAF, so a more competitive marketplace, more actors in there, different process technologies and assemblies of how those can be put together. All of these combinations, we need to start getting in there and getting this happening. So this is why we've identified measures that can reduce the investments costs to allow more actors into the field, really a key element of solving this, squaring this circle, as I put it.
Thank you. Luca, could I invite you to join? We have a few minutes and I have plenty of questions regarding SAF, e-fuels, hydrogen. I would like to put those questions to both of you. And I just probably have one question. We were talking hydrogen. And I have a question here, I think it's from, let me go back to it, Bertrand Geisling asking whether there is a benefit instead of having hydrogen-fueled aircraft to continue transforming that hydrogen into e-fuels and to keep this as an e-fuel, fuel rather. Would you see that possible?
That's a very hard question to answer because there's a whole bunch of elements to it. I'm just trying to come up with an easy answer for that. And even the most basic bits, it depends where the carbon's coming from, it depends where the hydrogen's coming from as to whether you'd come out ahead. One, perhaps in a more fundamental way, I think it's worth asking the question as to whether you need to be wedded to the kerosene fuel if there is a clear pathway to produce very low carbon hydrogen. And I think it's perhaps more fruitful to think of it that way, which is not so much, can you perpetuate that kerosene? Like it or not, the combustion of the kerosene does have other issues that the combustion of hydrogen doesn't. I mean, they each bring their own technical problems. But I think there is, perhaps it's worth almost putting this as an opportunity. And I think it's kind of the question that Stephen was asking in a way, which is, do we have to keep going with these complicated molecules? And there may be an opportunity here, in a sense, to transition to an alternative fuel, and that's, I think, one of the questions that's worth looking at.
Talking again about this dual supply between hydrogen and SAF, would this also, and I have a question anonymous, but nevertheless, would this require dual infrastructure at the airports?
So for hydrogen, certainly it would.
Is this affordable?
Well, we can't say as a matter of fact, but it looks certainly like it may not be affordable with existing business models, right? So it's about a redesign of the whole sector. The energy source is so fundamental to all of this. And what I would say about hydrogen is we probably have a lot of hydrogen to get into the energy system right now before we start talking about just H2 as a gas or liquefied hydrogen. So all of the SAFs, actually they get upgraded by the addition of hydrogen right now. So they're embodiments of renewable hydrogen at present. So I think the basic answer here is we need to get going, and we shouldn't be picking winners. We should be allowing for a large variety of solutions to contribute to the overall puzzle. And that's what it is right now. It's a puzzle, so we need a plurality of solutions.
Thank you, Stephen. We'll keep moving on with our next speakers. Just before I invite Tim to take the floor, remember that you can put your questions. We thank you very much for the many questions we received on the first part of this session regarding aviation. Now we're going to move from the air into the sea. So all the questions about maritime are welcome, and I will also pick some from yesterday that I wanted to keep for today. So on the right side of your screen, you have a chat box. Put on your name or anonymous, send button, and it comes here. So I'm waiting for your questions. Tim Scarbrough, you are Ricardo's lead consultant on quantifying maritime sector emissions. Your deep sector knowledge in the maritime transport sector has been drawn from shipping inventory and policy studies for the European Commission, UK government, and industry bodies. You have technical understanding of pollution abatement techniques as well as policies affecting the sector. You have an extensive experience managing and delivering industrial emission policy studies for the European Commission and UK governments. I'll stop there because there are many more things. You find it in the program. So Tim, over to you.
Thanks very much indeed, Alain. A very warm welcome. Thank you for having me. What I wanted to talk to you today about is some analysis that we've been doing at Ricardo of possible pathways for decarbonising the maritime sector. So I'm going to give you a bit of context for the work from a demand perspective and the ambition for the sector, talking you through the modelling work that we've been doing. And there'll be some parallels with what you've heard this morning from Luca. I will be talking about packages of measures and demand scenarios and things like that. And obviously, of most interest, the outcomes of the analysis that we've been doing and what the findings for the sectors will be. So if I just first introduce Ricardo, in case you're not aware of us, we have a vision of a world where we can all live sustainably. To realise that vision, we bring our diverse expertise to create novel and differentiating solutions for our clients' challenges. So on to the interesting stuff. We have been carrying out some work which is very much evidence-based. It's been describing the scientific understanding of decarbonisation possibilities in terms of fuels, technologies, operational measures. We've used input from external stakeholders, as well as then working to develop a model of ships and their emissions out to 2050. So this has involved ending up quantifying the emission reductions from different pathways of options, and I'll go into that in more detail. And we've done that against the context of a baseline of the demand for maritime freight forecast to continue rising, as shown on the right-hand side of your diagram. In contrast to Luca's presentation, we are taking as input to our model existing scenarios of demand forecast for the maritime sector. It's not an output of our model per se. So what's the context? The International Maritime Organization set an ambition level a few years ago now of a reduction of 50% emission reduction by 2050. That's the dotted red line you can see on the graphic. The projected business as usual emissions for the sector from the fourth greenhouse gas study from the IMO last year are shown fanning out in blue to grey above that. So you can see the challenge that's facing the sector. Of course, there are already short-term measures at the vessel level enacted by the IMO to begin to address that reduction, but it's clear from the level of ambition that it's going to require shifts to alternative fuels. And furthermore, we might expect that red dotted line could get lower if the IMO chooses to revise and tighten its level of ambition. So what are the options for decarbonising? There are many, and again, similarly to presentations earlier, they include technological options, operational measures, as well as alternative fuels. From a technology perspective, vessel design measures reduce vessel resistance and fuel consumption, such as hull coatings. Power assistance measures reduce main engine power demand, for example, flattener rotors. There are alternative propulsion technologies, different propellers, post-swirl fins, etc. There are engine technologies to improve engine and vessel efficiency, including enhanced fuel injection systems and so on. There's also the possibility for onboard carbon capture to directly capture the CO2 to be stored. The voyage optimization options would reduce fuel consumption by improving port logistics. There might be speed reduction, of course, weather rerouting. And last but by no means least, the future energy carriers. So alternative fuels, there's a range of those, and we'll come on to them. So based on our research into the possible options for decarbonising ships, we developed 3 distinct storylines, we call them packages, of plausible decarbonisation pathways to achieve that IMO ambition. Now, I should acknowledge that these 3 packages aren't necessarily a prediction of the most likely outcomes, but they're really to try to show the alternatives and the differences between them. So package 1 is an early pursuit of carbon-free alternative fuels. So it's hydrogen, ammonia. And this package reflects the view that adopting interim fuels such as LNG would perhaps be a diversion from focusing on the comprehensive decarbonisation of the sector as soon as possible. Package 2 is rather a moderate uptake of an interim alternative fuel, which we're using as LNG as the example. And then once available at scale, conventional fuels and LNG are switched for their drop-in replacement. So some parallels here with the earlier speakers in relation to drop-in sustainable aviation fuels. Package 3, in contrast to the first 2 packages, assumes an even higher level of uptake of energy efficiency technologies and operational measures in the short term to reduce fuel consumption, as well as later when available onboard CCS, carbon capture, and only later a transition from conventional fuels to methanol, ammonia, and bio-LNG. So just a brief word, this has been a detailed technical modelling study. It's been generating its own results based on a model that we've developed. It's a global vessel fleet model that's been constructed using input demand scenarios of a baseline, using pathways from the IMO's 4th greenhouse gas study. We've needed to estimate the future fleet, so there's a fleet turnover model in there, and it's looking at 10 different vessel types, different sizes, looking at new and existing ships, and looking out as far as 2050. And it outputs fuel consumption, greenhouse gas emissions from well to wake and a tank to wake perspective, as well as the costs, so annualized or net present value. And of course, from that, we get a cost effectiveness. So on to some results. This is my favorite slide, as I think it really helps to visualize differences between the packages. I hope it's big enough for you to see on the screen, and it's showing you the total fuel consumption of the packages and split by the fuel types. So you can see that there's common to all packages a significant drop in fuel consumption up to 2025 as the technology improvements on energy efficiency impacts the fleet. But beyond 2025, the technology improvements, whilst they continue to penetrate the fleet, they don't provide sufficient efficiency improvements to offset the increase in demand that is forecast. So the fuel consumption begins to rise again. So package 1, you can see, is dominated by ammonia. That's particularly from deep sea shipping, where that's assumed to be adopted. Short sea shipping is assumed to pick up the hydrogen slither. And then package 2, you can see that there's a sharper reduction in HFO and MDO, with an increased LNG, as I mentioned, as a short-term measure, with switches to drop-in fuels of bio-LNG from LNG and from HFO and MDO to biodiesels of FAME and HVO. And you can see that package 3 has got a sharper drop in fuel consumption based on the greater uptake of energy efficiency measures. And then there's a diversion into alternative fuels. You can see slithers there for ammonia, methanol, bio-LNG. So what does that mean from an emissions perspective? So this slide is showing you the well-to-wake greenhouse gas emission reductions of the three packages from the baseline scenario. So that's in black at the top, with our central demand scenario that's been used in the modeling. And it's showing you where the reduction's coming from. So whether reduction's coming from technology adoption, fuel switching, or CCS. And the results are telling us that energy efficiency technologies, whilst providing short-term greenhouse gas emission reductions, cannot alone meet the IMO's ambition level. The largest reductions do indeed come from well-to-wake emission savings from switching from conventional fuels. CCS, being a technology with higher risks, may not deliver savings, but could result in a small benefit. So all three packages meet the IMO ambition level under well-to-wake. And I should note that the IMO ambition was specified in terms of tank-to-wake. And as the supply of alternative fuels transitions towards a greater degree of renewability, so green fuels, much of that additional benefit will be seen in the well-to-tank component. So you can see under package one, initial reductions from adopting energy efficiency technologies. The fuel reduction impacts kick in the 2030s, assuming that future zero carbon fuels really begin as grey fuels before transitioning to blue and then to green variants. So package two, from a well-to-wake perspective, emissions drop similarly to package one. And I should note that the fuels used in package two, a reminder, this is more the drop in fuels, can be described as CO2 neutral rather than zero carbon, which was the focus for package one. So drop-in fuels still release carbon when combusted, and this is assumed to be countered by the absorption of carbon during fuel production. So if a tank-to-wake approach was taken, package two wouldn't meet the IMO ambition level. So package three has a greater greenhouse gas reduction from technology uptake than the first two packages, compensating a lower contribution from fuel switching. And there's an additional reduction from onboard CCS, which paired with methanol and bio-LNG leads to net capture of CO2 when considering well-to-wake. So that was from an emissions perspective. And how much will these different packages cost the industries? These graphs show you the additional net present value of the total cost of the packages over the period 2020 to 2050. The plot for each package shows you first on the left the costs that would be incurred under business as usual in the baseline, and then the increments pertaining to fuel, OPEX, and CAPEX before you're showing you the total bar. Overall, the three packages are estimated to lead to cost increases as a total cost, i.e. to fuel production and shipping industries, of between 3% and 11% from the baseline. So you can see that packages 1 and 3 are estimated to have overall similar cost increases of 3 to 4%, but they do have a very different breakdown of cost burden, with fuel cost savings and a much larger vessel CAPEX spend in package 3. Package 2, the drop-in fuels, estimated to be more expensive, about 11% above the baseline costs, and 3/4 of that increment would be fuel-related. So I've given you the results for emissions and costs on the previous slide. So this leads to findings related to cost effectiveness. So costs per tonne abated. This is a per tonne CO2 equivalent. So package 2, with the drop-in fuels, liquid and gaseous, comes out the highest cost per tonne abated because it has similar abatement but higher costs. Package 3, with the highest technology uptake, comes out with the lowest cost per tonne abated. Has similar costs but higher abatement numbers. Should say the numbers in this cost effectiveness are sensitive to the assumptions made, in particular on how to discount future costs and emissions. Though the comparison between which package has the highest or lowest cost per tonne abated don't change, which you can see on the right-hand sensitivity analyses. So with the central case assumptions of discounting both future costs and emissions by 10%, we find packages 1 and 3 cost per tonne abated similar or below current EU ETS prices. So I'm just noting that in the context of the recent Commission proposals in the EU for including the maritime sector in the EU ETS. So such a conclusion on cost effectiveness wouldn't be complete without asking why this wouldn't happen as a matter of course. So I know that we've already talked a little bit about barriers this morning in aviation. There's some similarities here in the maritime sector. So we also heard this morning for aviation, uncertainty of greenhouse gas reduction potential also applies to the maritime sector. It depends on the accounting methodology. And for methane, particularly, it would depend on the global warming potentials applied. The prices of alternative fuels are indeed very much higher than conventional fuels, HFO. That's a clear barrier. And of course, the bunkering infrastructure in ports would need to be upscaled. In some cases, that would need to start from scratch for new fuels, but of course, drop-in fuels wouldn't have that barrier. So the production increases for alternative fuels needs to be considerable, but the question is by how much, which fuels, at what location, and in which facilities, existing or new. In the maritime sector, we've got split incentives, principal agent problem. So, for example, charterers, who pays for the ship isn't necessarily the same as who pays for the fuel. That can be a barrier for the adoption of capital costs of new technologies. And then, as mentioned earlier as well, we'd need certification to ensure the origin of chemically identical fuels. So if we've got green or grey fuels, there needs to be certification in place to give assurance that they're delivering the reductions that are needed. So I'm conscious of time a little bit, so I'll focus just here on the right-hand side. So what are the implications for the fuel production industry? So we think that the fuel supplier's role in the transition and overcoming the barriers and reducing risks would be to help shortlist the fuel choices, because at the moment there are quite a few options on the table. And it can help to do that by supporting proof of concept demonstrations. And we're already seeing various fuel suppliers helping with the front runners in the field. They will ultimately need to accommodate the increased alternative fuel demands. So we had some numbers earlier for aviation sector, and the slightly higher numbers here overall for maritime sector of 10 to 14 etajoules per year by 2050. So they'll need to plan for the associated bunkering infrastructure and port refueling facilities, perhaps with the exception of drop-in fuels. And as mentioned, they'll need to provide the green certification and fuel sustainability information. And I would have thought to support the change to well-to-wake accounting from current tank-to-weight. So what are the implications for the maritime industry? Well, vessel designers and builders would need to incorporate best available energy efficiency technologies. The owners and operators should plan for new vessels investments soon, accounting for the additional technology and the fuel costs. And they may need to target green finance from banks. Vessel operators could lobby for regulatory changes to support zero carbon fuels uptake. Obviously, we're seeing the first strands of that beginning to emerge in Europe with the recent Fit for 55 package. And as fleets transition to alternative fuels, vessel operators will need to ensure the relevant fuels are available at the ports. So that will require early discussions with port operators to ensure the necessary infrastructure will be in place. The industry should monitor and support the future development of onboard CCS, but to note that CCS isn't necessarily needed if there's a rapid switch to zero carbon fuels. And as a final slide, the overall conclusions, there's a range of different fuel options being assessed. I showed multiple pathways of different alternative fuels that could reach the IMO ambition levels, but it remains to be seen if those ambition levels will tighten, which could place further constraints on the possible pathways. So of the packages that I described, all three would meet the IMO ambition level if well-to-wake accounting was adopted, but only the first and the third packages would meet the ambition on a tank-to-weight perspective. The drop-in fuel options would not meet that. Fuel costs are such a large component of total cost that energy efficiency measures to reduce fuel consumption are real total cost savers, so they should be supported. And the drop-in fuel package number 2, so thinking about biofuels of HVO and so on, and bio-LNG, they face fewer barriers to deployment, thinking about the infrastructure, but may well be more expensive compared to the fuel switches discussed in packages 1 and 2, which would require new vessel and engine investment, so burdens on other industries. And finally, similarly to aviation, long vessel lifetimes means that emission pathways become locked in for longer. So it's important, again, to act sooner rather than later to effect meaningful change. So that concludes my presentation. Thank you very much.
Thank you. Thank you very much, Tim, for this presentation. And, okay, I was wondering whether I was appearing on the screen or not. We have a few questions from the audience, and I see quite a number of questions referring to maritime and to your specific presentation. Not all of them can work in a panel, so I would probably put one question to you right away. And this relates between the refuel maritime that the Commission has prepared, or the proposal, and which of the 3 packages would best fit with the proposal as it is today, knowing it's only a proposal.
Yes, it's an interesting question, and obviously that refuel maritime proposals from the Commission will be placing as proposed, and obviously it remains to be seen how it will get debated in trilogue, but it will place obligations on the ship operators directly to reduce the greenhouse gas intensity of the fuels. And putting aside the import requirements to use shore power, which ultimately is quite a small proportion of fuel use, that will place an overall ratcheting down over time of the greenhouse gas intensity of fuels. And that doesn't give any clear indication to me of which fuels would get adopted, because each of those has different timescales involved. So as you would have seen from the packages, some of them have greater emphasis on the short term and some have greater emphasis on the long term. Now, the longer term options, for example, the zero carbon, ultimately provide the largest potential reduction. So one would expect, if you take a long term view, that those would be the lower risk options. So obviously, your fuel choices lead to a lock-in, considering the long lifetime of the vessels. So one might expect that if you take a very long-term view, the lowest carbon options would provide that security. But not all parties in the industry would be taking the longest-term view, depending on the particular arrangements, chartership or otherwise, that they have in the industry.
Building on your answer and looking into package 2, which shows that drop-in fuels, of course, have the obvious advantage to be available quicker and probably also with fewer barriers. Couldn't there be kind of a mix between 2 of those packages, where you start with this drop-in fuel and you wait until the other packages and their changes in technology for the vessels become more affordable, or I'd say are scaled up? Is this probably not one direction? And I don't know which of the 2 other packages would work together with number 2.
Absolutely, yeah. No, I agree that there's different factors at play in terms of drop-in fuels can come in sooner. Obviously, we've got other aspects to think about. We touched earlier today on the potential overlap with the aviation industry. That's quite clear. If there's similar feedstocks being used, I was interested by the points made earlier about the high quality versus the lower quality feedstocks. That could well ring true here for the maritime sector. It's been used to using lower grade fuels, and that could continue to happen. I should note that, again, as I said, those 3 pathways aren't the only possible options for how this will pan out in the sector. And so, as you say, different combinations of those could well entail. So, a slightly longer term waiting for the developments necessary, for example, to demonstrate at scale that ammonia works in engines and is deployable and can be produced directly as green ammonia first without using grey, would be another possible pathway, and that would come in a little bit later.
Yeah, I'm talking about ammonia. I see some questions about I'd say the challenges regarding ammonia. So we'll come back to that, because I think I would like to involve our next speaker to also contribute to that question. And with this, I will move to Jurrit Bergsma now for his presentation. So thank you very much, Tim. And hello, Jurrit. Good morning. Before I hand you the floor, let me briefly introduce you. You key focus on maritime energy transition, aimed at shaping techno-economic transition pathways. For the past 5 years, you fulfilled the role of business developer and business development manager for sustainable shipping, where you initiated and support, together with global stakeholders, key ecosystems for the acceleration of technology or regulation development related to sustainable shipping on behalf of TNO. You have, as an example, the Green Maritime Methanol Consortium and MACPI. The floor is yours, Jurrit.
Thank you very much, Alain. So welcome all, and thank you already previous speakers, because I already saw quite some interesting elements. I will shortly take you through what we have been doing in the Netherlands, and of course in an international context. It's aimed at the maritime energy transition and the alternative energy carriers and beyond in the maritime domain. So let me start with visualizing the way we perceive the critical developments within the maritime energy transition. The situation in which we are in today is that there is a clear societal demand. This is a picture you can see on the left below, that there's a challenge for, okay, how are we going to achieve this maritime energy transition that we want and need to be more sustainable? The phase that we see that we're currently in is the development of new types of vessels and vessel concepts, which require energy carriers, powertrain solutions, energy distribution, control mechanisms, so the design and validation of new ship concepts. The critical element in that we see at the moment is that we need all the stakeholders involved. We need the ports, we need the education and research societies, we need the financing industry, the government, the technology suppliers, the shipyards themselves, but also society. So the social acceptance of all the people that are involved in this picture. And above all, also the energy suppliers. I was really charmed with what Stephen already mentioned on the availability of the energy, and that we are in this together, so to say, that we all need to have the sustainable energy as a basic source to take the step towards a more sustainable sector in maritime, but also, of course, in aviation or trucking, you name it. So what we aim to do, at least in the Netherlands, and I think also internationally, is learning by doing. We're bringing all these stakeholders together into developing the vessels of the future. But opposed to, for example, aviation, there's not one concept which is more of a serial concept. Quite often vessels, especially the vessels developed and built in the Netherlands, are one-offs. So we need to learn by doing. So what we intend to do in 2025, between 2025 and 2030, is to build up to 50 near zero emission vessels of various ship types. So coastal, naval, fishing, dredging, offshore wind, which is part of a bigger financial ecosystem to try out and to learn by doing what these vessels do, how these technologies can be matured so that we can learn and decrease the risks and therefore cost of these new technologies. And by learning and doing, we can also bring back the information to the stakeholders again. And the overall aim of this is looking towards an horizon in 2030. That's the final stage, is that we have experience and confidence in the vessel types and technologies that have to be applied, but also the rules and regulations to be able to scale up these concepts. And that does not only apply to the vessels themselves, but also the parts, of course, in the energy carriers, the infrastructure required to operate these vessels, the crewing, so the educational system, and also the financial system, which is, in our opinion, one of the most critical elements to the overarching picture. Because not only in 2030, we need to be able to have the rules and regulation, technology, etc. available, but also confidence in the sustainable business case, which is required to apply these technologies and to scale up. And that will be one of the largest challenges of the coming years, that we together with also with other industries ensure that we can have a sustainable business case for the whole sector and that the perspective is in place and that the uncertainty that's currently in some way keeping the sector in an impasse can be transitioned towards actual action and taking really the next steps. So a little bit more detail, what are then the challenges that we see? It's quite a generic, but I think that clarifies, I think the main statements involved here. So we need the motive to act. there needs to be market demand, which is not only from the shipping companies, but also us as a consumer. We must be willing to pay a little bit extra to meet the societal requirements of being more sustainable. But also, on the other hand, we also need the regulatory requirements to act. The Fit for 55 is a clear example of, okay, we need to act, but how is it going to affect for the maritime domain? What are we really going to have to do? And of course, there's a big difference between inland shipping, short sea, and deep sea, and also the regulatory requirements that we perceive in that context. If we then go to the uncertainty, that's one of the things that is currently keeping us at our place. So what is the right energy carrier, and what's the availability going to be? What's the technology availability and applicability of those technologies? And as a result, the direction via strategic clarity needs to be clear on a relatively short term, and there are still a lot of elements under discussion. And that will be, I think, the biggest challenge on the real short term, is to provide a clear pathway towards this transition with sufficient support throughout the sector to act upon that. Because if we maintain the discussion with too many options for too long, there will be too much uncertainty to act. And that will be one of the main challenges for the sector as a whole. Clarify a little bit on what is happening and researched in the national view on the requirements of the sustainable energy carrier availability and what we need for the maritime, but also beyond sector in the Netherlands. So this is what is used in the Netherlands. That means also the bunkering. In petajoules, you see that over time between 2017 and 2050, there's a small growth towards deep sea shipping on the energy carrier requirements. But we also see that the energy demand is not decreasing significantly, so we compensate with being more efficient, but there's more demand to be expected over the next coming decades, which is to be taken into account. If we then look at what is an indicative pathway, we have two parts, of course, to it. The shipping, so the end users, we have two examples of the shipping and trucking, and also on the production side. So what we see at the moment is that on the end user side, there is a clear pathway at the moment between 20 and 2025 on the EU fuel regulation, which is being developed and finalized at the moment. We need the pilots to actually show that it's possible on a technical scale on the engine and the fuel cell development, and also the pilots on small scale infrastructure, so that we can also experience there and develop social acceptance on those regions where it might be difficult to implement such technologies, to have that step-by-step approach and get everybody on board of this pathway. And then around 2030, we see the market uptake and scale up, which is required, linked to the business case, which we expect. Which means on the energy production side, maybe even a bigger challenge, because we need to have that sustainable energy available. So we need renewable energy availability. We need to scale up the green energy, which is the building block for a lot of synthetic energy carriers. So we need the research on that development and the pilot plans, so that we can start to scale up of the hydrogen and the e-fuel plants towards full usage. This will be, I think, the key challenge. Is there sufficient energy available to become sustainable, and how can we actively pursue that process and also provide it where it's needed most in an effective way? For example, if we have sustainable electricity, does it make sense to make it into synthetic fuels, or do we first want to apply that to all the electrical demands on the shore side? These are choices that we need to make and we need to act upon. What we also see is that we have, as a key conclusion in the intermediate, that the structure of the future of the 2030 plus EU energy system is still very uncertain, and that a large-scale market uptake of e-fuel is not to be expected before 2030, because the availability is, at the moment, still a big, big challenge. If we then go to what we see as the solution, a little bit more in detail. So learning by doing in critical ecosystems. So what we try to achieve is to bring the stakeholders together to show what is done, but also to align the critical elements in the sustainable business case. So there are technical questions. So what's the impact of alternative fuels on the ship design and operation? How will the future power energy system look like? How can we compare solutions and make the right economic, technical choices in the early stages of ship design, but also throughout the broader system? And to start answering those questions, we initiated with several research projects. I will only clarify 2 of those, but just to give a view on what's going on, we have the Big Green Maritime Methanol Consortium to see whether this is a feasible solution, and also the Everlong Consortium, which aims at LNG combined with carbon capture as a potential solution. And there are many more like Magpie and Zero, maybe you already know it, but if you have any questions about those, I can also answer those in a later fashion. Now, I would like to clarify a little bit what we did in the Green Maritime Methanol. So what we did there is we focused on the critical barriers that we see. So safety guidelines for all stakeholders. How can we apply methanol, which also means on the level of local municipalities. Are they okay with handling methanol? But also on board, getting the education of the people aligned. What do we need to do this in a safe way? Then the technical basis, especially methanol, is quite easily applicable, but there are means to optimize the technology. Can you store methanol above the waterline? Very critical question, which could increase the amount of methanol that you can carry, increase the operational profile of your vessel, and really adds value to your concept. And again, most importantly, we see an economic turning point around 250 euro CO2 equivalent pricing for a feasible business case for biomethanol. And what's also a key element in this is that we looked at various ship types, and one of those key changes, and that's not really a big surprise, but local shipping types compared to deep sea are, of course, economically in an earlier stage feasible. So we looked at dredging, survey vessels, port patrol vessels, inland cable laying, and short sea container vessels. And we see that the business case is actually feasible on quite a short term. That means 3 to 5 years, also based on customer and charter prices that they foresee. So technology-wise and even economic-wise, we see that these concepts for specific ship types are not that far away, which is very beneficial for the nearby future. Just as an example, this is the broadness of such an ecosystem to clarify into what context we try to work together and get everybody on board of this process, which is also to some extent a social process of understanding each other's roles and responsibilities. Then a second project is towards LNG Zero, so linked to the Everlong, which is a concept on combining the use of LNG and potentially bioenergy with carbon capture and methane slip oxidation, which is a relatively short-term technology-wise applicable solution at a relatively okay price as we foresee it, at least on the shipborne side. So again, we did the safety guidelines for all stakeholders there. Technological basis to be applied, so we can also really develop and realize such a vessel on the relatively short term. And by combining LNG and carbon capture, there's an energy balance benefit between the two types of solutions, which makes it quite a cost-effective solution between a 50 or 80% capture rate of the CO2. So we're now moving towards really realizing such a vessel, and now one can imagine that the most ideal use case is an LNG-based CO2 carrier, to which you want to apply such a concept in such a way that you can actually capture the CO2 and store it on board of your CO2 storing capacity during the operation to prove such a technology, whether it's feasible or not. And so we expect on the standardized carbon capture solution an aimed price of 70 euros per ton CO2 emission for the onboard part, which is very competitive if you look at it also compared to other solutions. Again, various types of vessels applied, and we look at the full ecosystem combined with all the partners which are required to take these steps from class society to the research to the end users involved, which we think is the critical approach for various types of energy solutions. So what is our overarching vision that we try to work on? We really focus on the synergy between technology and the business case. So as clarified in the initial picture, we see today's sustainable shipping really as an exception, some tryouts, and it's understandable because we need to learn, it's quite expensive, the infrastructure is not available, but we want to take that step towards 2030, sustainable shipping as the investment norm. It should make sense by then if you buy or retrofit a vessel to make it a choice in a sustainable way, which does not per se mean 100% zero emission, but at least 80% emission reduction when you're making that investment decision, because otherwise we're not going to make it. It will take too long to make the transition as vessels have a lifetime of over 30 years. So we need the right landscape, so the boundary conditions in place on the infrastructural level, regulation, subsidies, so support for these business cases to ensure that we can take that step at first with some subsidies, and in the end it also needs to make sense to carbon tax, of course, emissions linked to that. And we need to learn how to do that, because there's also a lot of uncertainty in the business case of the vessels itself based upon technology inexperience. So by learning by doing, which is a critical process in the maritime sector, can really foresee and progress in our proposition within the EU of building these vessels, understanding how they need to be built. And we see that as the Netherlands as a key element. And what we, as a generalistic principle, uphold is, in the end, the rate of the transition is dependent on the rate of the development of the sustainable business case. Which of course there's a lot of nuancing need to be placed in this statement, but what we see is that when there's a commercial perspective on being sustainable, there is no argument against it. At that moment, if a shipping company says, okay, we see the business case, then they will act. And we need to make that transition in such a way that the technology, the boundary conditions, the consumers, us, and the social acceptance aligns in such a way that the sustainable business case becomes reality as soon as possible. And based upon that, we can progress this energy transition quite effectively. And I think we need the help of each other to achieve that. That's all I wanted to share today. So thank you for your attention. And I'm very curious what kind of questions there are.
Thank you very much, Jurrit. Yes, indeed. There are some questions. I have also a number of questions in the feed. Some of them will be added and mentioned in the panel. You've mentioned, there are 2 points I wanted to raise. You mentioned the first point about the uncertainties. You just referred again to that between now and 2030. And at the same time, you put 2030 as the no regret date or kind of starting point. How realistic is it to believe that we can meet, given the uncertainties, both on the fuel type, on the technologies, that we can meet the 2030 no regret time?
Challenge for sure, and the challenge will be that at that moment in time, most likely we need clarity. So if at the moment we're still discussing various solutions in 2030, we're not going to progress fast enough. And I think there is consensus about that we need clarity by then. And based upon that clarity, there can also be sufficient perspective for ship owners to act upon that. So we do foresee that that's feasible in 2030. But of course, it will be dependent on how the collaboration with the other sectors, energy availability will be discussed with all the stakeholders involved. So on a broad sense, yeah, we are quite confident that it happens, but it's an uncertain future. And in all honesty, we don't know 100% for sure.
Okay. Building again on the point you just made, you've referred to a number of technologies, and I had a question which also I noted. You don't mention at all HVO or FAME or anything in your mix. Is this something that's not part of your analysis, or these are drop-in fuels already there and you didn't look at them?
Yeah, we do take them into account, and we see that as part of the solution, definitely, as part of the mix in the upcoming years, but we also, of course, see the limitation. So we see that it's a share of what can be added to the mix. However, the limitations and the impact on global, let's say the areas where this energy needs to come from, where the let's say the natural oils come from in the plantations, etc. There are clear limitations, and we see it as a part of the mix, but not the key part, which will make the let's say the majority of the energy carrier what we are going to use.
Last question before we move to the panel. You mentioned uncertainties. I'm coming back to that point again. How much does social acceptance add to the technical or regulatory uncertainties?
Quite a bit. Actually, what we see is that there's a lot of technology-based solutions. So we are quite confident, and everybody sees, okay, we can do this. We see the feasibility. But what we also noticed in these projects, while learning by doing, is that when we talk to local municipalities throughout the Netherlands and also international, that when we try to do a trial with hydrogen or ammonia or methanol, there are a lot of people who think that's a scary thing to do. which makes sense. It's something different. We need the experience to do so. So how do you take everybody along in that route that it is safe if you take the right precautions, if you take the right steps? And what are the considerations? And we see that can sometimes take 1 year, 2 years, 3 years to achieve that. So it's quite a significant barrier. A secondary part of that social acceptance is also more on the economic side. Are we willing to pay a little bit extra for being sustainable? And that's also a part of social acceptance, because if we don't earn enough money to be able to pay something extra, it's going to be very difficult.
Okay, thank you. Let's now turn to all of our panelists and have everybody. And I would like to welcome Damien Valdenaire, who is a science executive for refining technology at Concawe, and you hold this position since 2016. Welcome, Damien, on stage. You've been involved within Concawe since 2014. You are seconded by your company, TotalEnergies. And in your position, you lead studies regarding the impact of regulation on the refining industry, from product quality to CO2 intensity of refined products, ETS, etc. And you also contribute in projects such as the Refinery of the Future, and in a low-carbon economy. Damien, you've heard two sectors, aviation, maritime. They've been talking a lot about the different fuel options, and I'm looking at you as a refining expert. What can you do to help them?
Yeah. So here behind your question, you raise the topic of the supply and demand. So what should come first, supply or demand? So I do believe that here the demand has to come first, and you may wonder why it has to come first. It's possible to bring a new product on the market when there's no demand, and so you create a demand. And this is, for example, what happened 15 years ago with the smartphone. Basically, there were no demand for smartphone. We didn't know that we would love to have it. Basically, when you bring an innovative technology, when you create a new usage, the consumer may want it, but you need to find something new. And here, for the energy carrier that we are looking for, or the low-carbon energy carrier, basically a ship or a plane will still move from a place A to a place B, transport goods, and so the value you are bringing to the system with a new energy carrier basically will not necessarily change. So what the speakers explained before, that you need to create a business model. And what we see today, that the business model does not exist, basically because the cost is too high, in fact. So the point of cost is key. So what we can do as refiner, basically, is to inform the sectors, aviation and shipping, of which are our constraints as fuel producers. Constraint in terms of timing, constraint in terms of potential cost, what we assume today, and inform about the technologies, where we are in terms of technology development. So I think this is what we can do today, is to come closer to these sectors and to explain which are our constraints, and ultimately to make the demand being created. Because once the demand is created, I believe that refiners and all the fuel producers will adapt. So this is the way I would answer to your question, Alain.
Thank you, Damien. There has been a significant shift not such a long time ago when we moved to the low sulfur maritime fuel. Mm-hmm. How much this experience can help the industry to adapt to the new fuels?
So indeed, as you mentioned, I arrived in Concawe in 2016 when we started to speak about this global sulfur cap, so to speak, when we were very soon close to get the confirmation of 2020 as the date for the global sulfur cap. And what I realized at that time, refiners and fuel producers and the consumers, the maritime sector, didn't speak much together. Or at least I would say the constraints of both sectors were not really understood. So what was key in this transition was to get these sectors coming together, to explain their constraints, to bring the knowledge in terms of technology, in terms of cost, and then having technology neutrality. Basically, the fuel consumer, so the ships has the choice between the new fuel and a scrubber, but having this technology neutrality in place, the actors made their choice. So the learning from this transition, that when you put close together two sectors, and when they speak together between each other, basically the actors will make their decision. And if you are technology neutral, if you leave competition happening, the system and the market will balance to get in the end a smooth transition.
Okay. Today we have one unique fuel for aviation, that's jet fuel, two for maritime, heavy fuel oil and marine gas oil. We'll see what comes in the future, but the first question, and now I'm asking each of the panelists here, could there be a competition between aviation and maritime for those new fuels? Stephen, maybe you can start.
As I tried to point out, I would be concerned that that could be the case. So I think the common thread in everything we heard this morning for aviation and maritime is actually the word hydrogen. We're talking about hydrogenating, hydrogenated vegetable oil, ammonia, a hydrogen carrier, hydrogen itself, methanol, another hydrogen carrier. So there's potential there for a competition for the supply of hydrogen unless we have a massive oversupply. So this is something that I think we do need to look at. And I mean, I look at things from a research point of view, right? So in the laboratory and what we physically see we can do in the laboratory. And if we boil that down, this concept of associating the quality of the feedstock with the quality of the application, I think is a way to help think about this.
Okay. Any one of you wants to intervene?
Yeah, I'd be happy to follow up on that one. I agree that the potential for overlaps and competition includes with hydrogen. I think a lot of the work that we've been doing has identified actually there's opportunities for countries rich in renewable resources to develop hydrogen production facilities, but they would need to be on top of an additional production facilities compared to their existing demand for electricity to avoid any competition concerns with the local demand for electricity. But then again, yes, the demand for hydrogen could conflict with aviation. We've also talked today about the feedstocks for biofuels as well, being another possible conflict. And I think, and I'm not an aviation expert, so I'm not professing to know that much about it, but from what you were saying earlier on, Luca and Stephen, the challenge for aviation is really perhaps greater than for maritime. There are greater constraints from a space and weight perspective, as well as fuel quality perspectives, which means that perhaps, given all sectors need to decarbonize and rapidly, with that being perhaps a greater constraint for aviation industry, we should ensure that there isn't an additional barrier for aviation in a potential conflict of demand from the maritime sector.
Luca?
Happy to comment as well, yeah. I think in the near term, there is definitely a question of competition as we're rolling out a lot of these new technologies. But I think it's also important not to lose sight of the fact, much as it is now with the fossil slate of products, those products are complementary. I think this is a point that Stephen was making, which is that they're not actually in direct competition because they're a different part of the slate. And the other piece the other way that these different sectors and sectoral demands are not in competition is that one of the key things that's needed for these green technologies to be viable is scale. So in that sense, in a longer term perspective, actually the fact that more than one sector has demand for these technologies is actually an enabler of the solution for all of them. Yes, near-term competition, but actually in a bigger system perspective, these sectors are complementary and actually can make the solutions more viable for each other and for themselves.
Thank you.
I fully agree with that statement, and I even would like to bring the discussion one step more fundamental towards the availability of energy in itself. So the energy carrier is, of course, the way we want to apply it in the different domains. but the first step is to have that sufficient level of energy available to move towards synthetic fuels or elements like that. And it's more on the synthetic fuels than on the bio side, but still it's I think a key element that we need to foresee. So how do we expect that energy availability to develop over the coming years, and how that is going to affect on the long-term availability and the capacity to scale up towards synthetic fuels on the lower and higher end of the spectrum.
Yeah, sure. I can comment it as well on this one. I think competition is great because in the end, competition will develop research and development, and we need more research in this area, both for maritime and aviation. So having competition will push the research, but then we shouldn't, in a sense, lose ourselves looking at the ultimate and final solution. So what will be exactly the scenario by 2050? So what Tim showed with the different package that we don't know, we see different kind of paths. So we will find out. But today it doesn't. Even if we don't know what will be 2050, it doesn't prevent today to act now. What we see that energy efficiency can bring value in decreasing the CO2 emissions, and it makes sense in terms of CO2 abatement cost. So even if you don't know the ultimate solution, there will be a lot of intermediate steps, and we can start now. And the system will find out. If you have competition, you will develop more research, you will find new solutions, and the system will go on. So this is what I can comment on this one.
Thank you, Damien. Maybe diving in some more specific type of energy sources. LNG plus CCS and onboard CCS. In your scenarios, Tim, you only have CCS in package 3, which is a very limited share, and it comes basically to do the extra mile to come to climate neutrality in the sector. Jurrit, you referred to this project where we have this LNG and onboard CCS technology, but isn't there a more fundamental challenge with LNG, which is the methane emissions today? And is this something that can be technically easily tackled, or is this a real risk for that LNG route?
Yeah, it is a risk. Oh, sorry, Tim, please go ahead.
Definitely a risk. You're right to highlight it. The risks are both upstream and downstream. You've got, at the point of use, you've got the issue of potential methane slip with the engines, but I think there are some of the technical solutions there. The high-speed diesel cycle dual fuel engines have got low methane slip, so that's a good solution, even if they're not currently used to a larger extent. I think my understanding is it's more the low-speed variants that are deployed to a greater extent. I should note, just a reminder, the methane slip would still be a problem for the bio-based versions as well, so we shouldn't forget that. But there's also the upstream component as well. Future releases still remains a problem in the fact that it's a real world problem. We've also got variations on how we might account for it. And I think perhaps we need to provide a bit more certainty about how we account for it, because obviously there's different global warming potentials that could be applied for methane, for example, with a greater emphasis on the shorter term with a 20-year GWP, which if there's that foresight early on enough for potential adopters of these types of fuels, that might help inform their decisions a bit more about whether to invest in those sorts of solutions.
Yeah, I agree. What I do see at the moment is that the impact of methane slip is not sufficiently accounted for in the current, let's say, the way we account the methane slip in itself. There are sufficient, let's say, technological solutions to be applied on vessels which can support this the application of LNG in itself. There will always be some methane slip in the operation, in the whole stream, in the bunkering, you name it. So that will remain a component of the picture. And that's one of the questions that we need to answer, what the current impact is throughout that whole chain. And I think there's insufficiently clear what the impact is. But on the technology side, the integration of carbon capture and methane slip oxidation can provide, I think, a very significant greenhouse gas reduction, which makes it an effective solution for some ship types. Of course, with such a technology, you have to take into account, especially with carbon capture, that it takes space, it takes certain infrastructure requirements as well. So you have to take probably into account, okay, what's going to be the number of vessels to which such a technology can be applied and that it's effective.
No, Damien, you just shout when you want to contribute.
Thank
you. No, it was definitely for the maritime experts. Looking into ammonia, which is another of the fuels that is really very regularly mentioned as one of the main routes for decarbonizing the shipping industry, there are also some challenges around ammonia. And I have one here for a question from Bertrand Geisling talking about ammonia combustion works only with lower speed engine because of lower flame speed, but hydrogen works with fine with mixed diesel or even pure. Is this something that could be a hurdle for the ammonia route?
I'm happy to pick this question up. My understanding is that yes, indeed, the state of research on ammonia combustion in engines is such that you do need to account for its lower flame speed propagation. And you might well need to complement the ammonia with another pilot fuel, whether that could be, for example, on a vessel, the hydrogen cracked from ammonia already stored, or whether you need to complement it with a diesel-based fuel is currently unclear. And I think this is why, as Jurrit was explaining earlier in his presentation, the need to do more sort of tried out projects. And there's a lot of research going on at the moment. I was noticing the most recent announcements from Maersk, who have been announcing their investments into methanol. And when challenged about ammonia, they're indicating, yes, it's not a solution today, but research is ongoing, effectively. So it's be interesting to see how that research pans out.
I just want to add something, even though this was a sort of ostensibly a maritime question. I think one of the reasons ammonia is getting so much interest is it's also one of the options for hydrogen transport, right? So it's a system question. If you're going to have hydrogen as a commodity energy vector, it's going to be shipped around, and one of the options for that is ammonia. So if you are shipping ammonia around anyway, you also have to ask the question of should you be using it as a fuel. So I'm not going to comment on the technical side of it because that's not my area, but it's important to view this in the broad energy system question that is driving a lot of the interest.
And what we currently see in most of the discussions considering ammonia, and I fully agree with the system statement, is the level of the safety acceptance as more critical even than the operational elements in the combustion. I think those are feasible solutions. But the safety and the acceptance of having large amounts of ammonia, even more than what we currently see and broadly applied, I think that will be a key barrier to surpass as a sector.
Talking about safety acceptance, wouldn't we face the same with hydrogen in airplanes?
To me, certainly, right? So it's all the points touched on there. It's a systemic solution is what's needed. If I could go back to ammonia just for a moment. So the purpose is to store and transport hydrogen and then convert that to water. We get our energy. So what is the best way to do that in a given energy system? It was taken by Tim's charts over a long time scale, and also what Damien had said. We don't need to pick winners now, right? So as we deploy more and more hydrogen and other renewable energy sources through different vectors, how the system is going to reconfigure itself around that. And what we need to be concentrated on doing is building our competence and continuing our research. So perhaps ammonia is not the number one option. Maybe it is for shipping right now, but we absolutely need to continue our research and development on the key challenges there, of which combustor design is definitely one. Similarly for hydrogen then, perhaps hydrogen usage in an aircraft technology is a little bit more far-fetched than in other places, but that doesn't mean we should rule it out and we should continue our work. But certainly there would be, aviation is about safety. That's why the certification methodologies are there for synthetic kerosenes. So safety is of paramount importance, obviously, if you're at 40,000 feet.
Yeah,
right.
Definitely. Continuing research, that's fine. Developing the technologies at industrial scale is the next stage after that. But I'm still remembering your no regret timing of 2030. Is this time frame that is left between today and the research required for big, I'd say, big choices, hydrogen route or not, is this something still realistic to come there? Or will we be challenged? And the second part of the question, e-fuels today seems to be a way to create drop-in fuels from the hydrogen bases. Wouldn't that be the easier way out?
I may answer that. So there are two elements in that question. I think 2030 is going to be critical towards that choice. And I think we always underestimate what we can do on the long term, step by step. And we overestimate what we can do tomorrow. So the world is so very different than it was 5 years ago, or even 10 years ago, if you consider where we are standing at the moment and the future that we foresee. So in that respect, 2030, also given where we need to go in the emission reduction aims that we foresee in global perspective, it's a matter of choices. And I think their urgency is so high that in 2030, there needs to be clarity in how we're going to move forward. And that doesn't mean any absolute clarity. Of course, there should be sufficient room on different types of solutions. But again, that economic perspective needs to be in place to make the change towards sustainability in line with what most likely will come out of the Glasgow Climate Convention. And linked to that, if you want to look at, okay, which types of steps and solutions are then going to be in place, that's also up to the market and to the solutions that are required to act upon it. Oh.
Anyone else?
I could add just a little bit. I agree with all of the things you said, Jurrit. Thanks for that. That there is the potential role for regulators to try to push in the direction of the outcomes that are needed. Obviously, the outcomes needed are greenhouse gas emission reductions, and to not pick winners. And so placing constraints from a carbon or greenhouse gas perspective, overall CO2e, is the way to sort of gently force that issue. And we've seen in the past European action preceding international action in the likes of monitoring, reporting, verification for shipping emissions, started off in the EU and then led to the DCS data collection system at international level, and with the recent proposals for trying to put a price on carbon from ships in the EU ETS, recent proposals from the Commission, as well as the as mentioned earlier, the Refuel Maritime proposals, the Fuel EU Maritime proposals, I should say, that those are nudging in the right direction, and hopefully that can provide the clarity, as you're saying, Jurrit, in the 2030 timescales needed to make sure that all the key decision makers and investors can make the right decisions that are going to still affect carbon emissions in 2050.
Okay. When it comes to the international dimension of those two sectors, we are, of course, thinking European legislation, European regulatory framework, but we need to get this beyond the EU. You will not be able to drive the change at the same pace if you don't have some infrastructure that is developed in other regions, because these are the regions where you will have to travel to, whatever it's a plane or a ship. how difficult will it be to get those broad international organizations to take the same route at the same pace as the EU?
I think I can at least comment on some of that. I think there's been a bit of a shift recently. So the conventional approach was to wait for the international organizations to drive this change. I think what you can see emerging in the EU, for instance, the way the Refuel EU proposal is structured, it imposes the requirement not on the economic operators but on the fuel suppliers, and then that basically means that the fuel supply in the EU will have these lower carbon characteristics, and effectively is imposed on actors from around the globe in the case of aviation, because if they fly into Europe, they will be buying low carbon fuel. And that kind of construct is, I think, what will allow the EU to continue to drive this change. And it is a complicated question, and it's been a very thorny one. And this, the common but differentiated responsibility part of this has also been a major obstacle to the international frameworks moving forward, and why it took ICAO so long to reach the agreements that they have. So I think there are ways and sort of carefully structured policies such as the Refuel EU proposal will allow, I think, hopefully act as the catalyst for this transformation that everybody's looking for.
So,
Steve, go ahead, and then you, Jurrit.
Thank you. So just to echo what was previously said, and I think there's two tenets that make that work internationally. The first is that the solutions are drop-in. Okay, so if as long as they're supply-led solutions and that they're compatible with existing infrastructure, then they can be used in existing infrastructure, and that can be turned on as soon as supply is ready. And then I wanted to really highlight what Damien had said about generating demand. I think this is the key thing that can drive international deployment. If we can get the consumers engaged and really ask in the aviation case, their airlines to supply this stuff to us that we wanted, then this can really start to turn the wheel.
Talking about costs, because that's another impact. The options that we have been discussing here, those that have been attracting most of the questions and are probably also promising, despite some barriers, thinking of ammonia, I'm thinking of hydrogen, of course. These will turn out to be much more expensive than a shift towards bio-based products, or do you not see a big gap there? Second part of the question is, could this also trigger a different solutions that could be adopted beyond globally?
Yeah, just to clarify the way we foresee this transition at the moment, so both locally and globally. So what we see at the moment is that there are local niches where it makes sense to be more sustainable, where these technologies are to be applied, developed, which are, let's say, the more extreme scenarios. So working with hydrogen, ammonia. We have a nature reserve in the north of the Netherlands, which are vessels, passenger vessels, where it makes sense to be more sustainable. And that provides confidence to develop these rules and regulations which are required for global usage of these technologies. And on a global level, we see that there should be at least a minimum requirement aligned with what the global aims for emission reduction are. So this is really the common denominator between all the countries and all the global aims from Paris, with the Paris Agreement and the Glasgow Agreement that's going to come into place in the coming next months. And there we have, let's say, together this transition path of the minimum that we need to achieve globally, which there should be a minimum consensus on, and the new technology supplied in these niches on which we can base the future, let's say, lowest common denominator where we should act upon. So that's the two-way approach that we currently see.
May I add to that? You ask about costs. The cost trajectories for conventional fuels and alternative fuels are, I would say, going in different directions. The question is, at what point do they begin to meet and the alternative fuels become cheaper? their prices are coming down. Obviously, the range of different sorts of projects which are going to increase demand, the likes of which Jurrit, you explained earlier, will help to drive costs down, and the sort of the prime movers who are making first demands on the supply are going to further drive prices down. And I think we see, thinking about the e-fuels and the hydrogen production, if that's largely driven, for example, from solar PV, the price of that continues to fall. So those sorts of new plants would, you'd expect prices to continue to drop. So, but obviously in the short term, they are still more expensive, and that remains the barrier. As to whether they are more, the biofuels are going to prove to be cheaper or more expensive, I think this is where we perhaps have a greater potential for supply constraints in terms of the feedstock availability. So that perhaps poses a greater risk in the long term, but obviously we're not at the point where we're limited in that. So I think there's more uncertainty in that area.
Thank you.
If I could just
yes.
I think I agree with the point that Jurrit made about the niche markets. I think it's really instructive to look also, first of all, there are a bunch of niche applications where these more expensive fuels are already economically viable. So that those are very good test beds to prove out the technology, as Jurrit said. But then if you take a look perhaps from road transport and look at low emissions and zero emission zones in urban areas, you start to see where a different driver, in that case public health, is driving the development of new technology options. And it's not going to apply everywhere, obviously. But in that case, it's not just about a calculus of comparing the cost of the fuel, one fuel versus another, but you have a whole series of other drivers that also come and weigh in. And those are the things that tip the balance on whether technology options are commercially viable or not.
Damien?
Maybe I can comment on this one. So yeah, today the fuel, the cost is an issue, and because you don't create a business model because of the fuel, the price is higher. Because being in a highly competitive environment, both for shipping and maritime, basically, if one actor today is deciding to go to a low carbon fuels, which will be higher, he will lose in terms of competitiveness. So he will lose some market share. But in a longer future, when you you create this demand, and if these operators have to use this kind of fuels, basically the cost is decreasing in terms of relevance. And the question is becoming, what will be the cost? The question is more, will this higher cost impact on the demand? So the demand for the maritime transport to transport goods. And we see for maritime sector that the fuel is a big share of operating cost today, and it will be as well in the future. But if you compare to the value of the goods which are transported, it's not so important. And on shipping, on aviation, it's a bit different, as the cost of fuel in the price ticket is quite higher. So the key question is that will it impact the demand in fact? But if it's a constraint that all competitors are facing, in the end, the price itself is not so relevant. The question is that will it impact the demand or not, in fact?
Thank you, Damien. We're getting close to the end of the panel, but I would like to put a closing question, which I saw here in the feed. I'd say a bit of thought-provoking question to all of you, so you just respond one after the other. Are the choices for the transport sector outside its control determined by availability of low-carbon power, by development of supply of biomass? So basically, will this not rather be driving the choices than technology choices that doesn't look at availability? Who wants to start?
Well, yeah, if I may, I would like to start. There's also always the question of what's your level of control, your influence that you have. I think the essence is that it's not an individual responsibility. We have to do this together with all the stakeholders involved. And we have to get the right facts on the table to make the right choices. That's the key challenge that we have at the moment. And all the stakeholders are part of getting those facts on the table. What kind of solution makes sense on board of a vessel, on board of a plane, on board of a truck. And in that sense, we have clear influence because we try to come up with the best solution throughout the full system of having sustainable energy carriers available for the transport of our goods and passengers. And I think that's going to be the key question. So is it out of our control? Definitely not. But we have to make clear choices where we put our chips in and where our facts come from to help making the right decision in the coming decades. So that would be my view on this.
Yeah.
Stephen?
I would agree, take the same view. And maybe a thing to consider is aviation, maritime. Okay, there are disadvantages there in terms of technical requirements that they place on the fuel, but they have advantages in terms of organizational capacity. So airlines are very important customers for fuel suppliers. They can, to an extent, ask or maybe dictate what the fuel supply should be. The same is true of ports and airports. Okay, so those are demand-side measures that those sectors have that, for example, the individual passenger doesn't have the same organizational capacity. So it certainly is within the influence, maybe not the control, but the influence of the sectors.
Yeah, and if I could add, I guess, just to pick up on what Jurrit was saying, I think thinking of it in terms of really trying to understand what the right options are to have on the table is the key thing right now. So there's, part of the history of biofuels, right, is a huge hype and then a lot of loss of confidence in the fact that biofuels are actually a solution. And we're still fundamentally trying to address that question: which routes work, which ones are actually potentially helpful to have in the basket, and that, I think that's where we're at, which is to not pick and choose. It's not an either or. We know most of these sectors have fleets that tick over very, very slowly. So we are talking 20, 30 years that we need just to replace these fleets. And so we need alternative fuels that are lower carbon, that can still be used in the existing infrastructure. And a lot of those biofuel routes are right now some of the lowest cost options that we have to get those fuels. Is that the ultimate answer? Nobody knows, right? That's definitely crystal ball gazing. But is it part of the pathway in that transition, and possibly a longer term element as well? I would say yes.
Tim, Damien?
Yeah, just a final point from me. I agree with all of what's been said so far. I wouldn't want it to be read into that, we're seeing these potential challenges of potential constraints or opposing from each sector to lead to a delay in making decisions, because clearly the decarbonisation agenda, it needs to be considered very rapidly. The research that's ongoing is ongoing already to try to resolve the uncertainties that exist from a technical perspective. And I think some of these potential constraints between fuels, between sectors, and the choices between them will need to be ironed out as a matter of course. But that shouldn't delay progress that needs to happen from now.
Damien, the closing word?
Closing word?
Yes.
Word. Okay. I think that the role and the responsibility of the fuel suppliers is to inform the global community on where we are in terms of research, where we are in terms of constraints, where we are in terms of timing to develop new fuels. And because in the end, this is the final operator who's going to make the decision to go to energy efficiency, to switch to a new fuel. And in the end, the question here is, will biofuel be the one winner and being the unique fuels for aviation and maritime by 2050? I I think from what we've seen this morning, the answer is no. There will be multiple solutions because of this multiple cases, there's multiple needs, and for sure here we speak about a global solution, not only Europe. We know that the rest of the world will have to follow. So, but as we just said, it doesn't prevent to start now, because we know we can start, and we will learn by doing. And it doesn't mean that what we will do tomorrow will be wrong. No, we will learn, it will improve the system, and in 2050, we will do things we can hardly imagine today, I believe.
On this very positive conclusion, thank you very much, Damien. Thank you very much, Luca, Tim, Jurrit, and Stephen. I think it was a great discussion, great presentations. I thank everybody for having joined this first session of today. Our final session this afternoon will start at 3 o'clock, and we'll be looking into the fuels towards alternative fuels towards 2050. Thank you very much, and see you at 3 o'clock CET. Thank you.